I'm Mark Dahl, and I've been working at Boeing for over 40 years, and a lot of that has been on a journey to do what I'm going to talk about today. I'm responsible for a huge number of technical documents that we've been slowly migrating into a form that can be used as direct data access versus people reading documents. So let's see, who's?
Just down there.
Down there, okay. So yeah, out of the collection of documents that we're migrating, there's a set that do represent 40% of Boeing's product definition. That we're talking about the design of all Boeing products, whether it's commercial or military. This data is highly interconnected. It's a very complicated search space. In trying to move towards in support of a digital thread, we're looking at, we're migrating to RDF. I'll talk about that. And the way that we're doing that in MarkLogic is interesting. We're using embedded triples. We're doing an incremental transformation. So more on that. And we are using AI to support the whole migration effort in a very focused way. And also, is beyond content management, we're looking at how to use MarkLogic to distribute the data. This is not the first, we're on a journey, so we've done this sort of thing before, but we're looking at MarkLogic to help scale what we've done to a much larger degree. I'm getting some feedback, is that okay? Anyway. So the whole set of standards that we're migrating, we call them product standards, and they include all kinds of information. You can see at the bottom, they're design standards used by design engineers, design guides, design manuals. There's manufacturing data that have to do with how facilities are put together, how tools that we create in order to support manufacturing, the operation and distribution standards, how manufacturing items move from place to place. But the focus that when we're talking about the data that comprises the product definition, it's this standardized product definition box up here. There's 3 basic categories. There's part standards. Those would be all the common things like fasteners and brackets and connectors, things that you'd buy as commodity items. And then there's material specifications, so all of our parts are made out of some sort of material, and these are the specifications that dictate what the engineering requirements are, who you can buy the materials from, and the basic it's engineering properties. Then there's process specifications that have to do with manufacturing processes that are used to fabricate parts or build assemblies. There's a whole host of those, fastener installation, electrical bonding ground, heat-treated materials. There's hundreds of those. And these specifications, again, they're mostly in document form, but they're giving you the requirements that ends up being work instructions that mechanics operate with and quality buys off against. And you can see there's some color coding here. So the green stuff, we have modeled that stuff 100% for commercial airplanes. So every single part standard, we have a representation such that people don't have to read documents anymore. They just call services, and those services are available across the product lifecycle. These other areas, you can see there's just a couple that are in yellow, and what that really means is that those specifications that are really primarily document-based, we've made some progress in modeling those things, but the way we've done it is just not scalable, and that's what I want to get into. What we're going to, the approach we have with MarkLogic is going to turn that around, I think. So the one with part standards, we're talking about, 10,000 some documents that represent actual billions of individual potential part numbers, and it's all service-based access. So we're in good shape there. But this other stuff, it's more narrative. It's not as formulated as part standards documents. So the product standards we're talking about, they originally all were in book form. I don't know if you can see up there, but there's a picture of a bookshelf, and that used to be the old days. Those bookshelves were distributed across the company, design, manufacturing. Everybody had to have a bookshelf like that. And then now they're in PDF form, but they're still basically documents. And they are used from, really conceptualization of a product, preliminary design, the design phase, all the procurement we have to do for materials, and we have suppliers that build per our design, and then there's manufacturing and maintenance. These standards are used through the whole life cycle. And we support existing in-service airplanes, anything that's in service we have to support. And everything that's being built and everything that will be built, our standards support that whole range. So we have a very long life cycle of the documents. And we have a lot of different needs we have some people that still, mom and pop shops that still work with the paper, to some of our suppliers have advanced systems and different flavors of model-based design. And our data has to be open-ended and support all those needs. There's also a very large search space. So, an individual airplane might be in the order of 1 million parts, but it's represented. The details that we're talking about are called out in notes, which are an order of magnitude larger. Then there's specifications called out in those notes. That's going to be larger. And then if you get into, our documents are highly interconnected. So they form spec paths from one spec to another. And if you look at those numbers, you're in the billion range. And if you look at all the specs along those paths, you're in the 30 billion range. So we just have a very complicated search space that's large. And the one part about this, it's not a search you couldn't use a Google search. You have to, when you're manufacturing an airplane and you want to know what's the torque value, I have to apply to this specific bolt with this material stack up. There's only one right answer, and you have to find it through the search space. So it's not about approximation or just good enough. There's no good, 100% is good enough. Everything else is not. So here's an example. This is actually a network. All these, it's a spec calling spec network, and they're all referring in this case to a particular cleaning spec. In the manufacturing process, you usually have to cleaning a part as part of the operation. So this is just one part of the network referring to this one spec. And there's more than just, there's context here. So whenever you're traveling along a link, you have to keep the context of where you came from in order to interpret where you're going. And these specs are very reusable, so they have a lot of different contexts they appear in. So this is kind of part of the problem. We have an existing system that is the single source authority for all this data. It's an XML system called Decado. We have structured content, but most of it's document-based. So one reason we're moving to MarkLogic is because Decado is at the end of life, and we have to move off of it. But the other big reason is because we want to move into more of a using data model, semantic modeling, whatever you want to call it. So structuring that allows access, direct access by other systems. So we have a set of systems already. You can see there's a pattern here where standards are used. The same sort of, we have a set of systems that deliver information to the same pattern. The blue bubbles here are design, and green is manufacturing, and orange is customer support. There's a set of applications that deliver specific kinds of data. That could be CAD data, work instructions, and so forth. But it's incomplete, like that other picture I showed, where the most complete part is the standard part data, but the engineering specifications for materials and processes are, we're just starting on that. So we're the migration process. We have this old Decado system, and we have, 1.5 million things to migrate about. And there's the extraction part. They have to do a transformation to get it to something you can load into MarkLogic, and then we're loading into MarkLogic, and we're using another system called RSuite that sits on top of MarkLogic. I think there's another talk that's going on right now, and that we use RSuite primarily for the authoring function and also publications. We publish. Our publication pipeline runs through RSuite. The way we operate is we can work at the RSuite level, or we can work at the MarkLogic level. So there's certain things we need to do in MarkLogic. We just stay at that level. So one of the things is, so we're loading into MarkLogic, and then we have something called registration that makes things visible to RSuite. And we're doing that because we need to operate at both levels. Anyway, there's a whole talk going on tomorrow that's going to deep dive into how we do that, how we load and register content. So I won't talk about that anymore here. So here's our kind of high-level architecture. MarkLogic is our content management system, so you can see that there's MarkLogic in RSuite, and then there's these other authoring kind of tools that are sitting around it. We're using Oxygen, and there's some other data-centric authoring tools we're using. At the bottom is more the semantic modeling stuff. We're using managing an ontology in language called, well, it's RDF, but the ontology is in Shackle. There's model-based spec authoring. This is stuff that's mostly, there's teams working on the ontology, but the ontology isn't integrated with MarkLogic yet. And there's other work in terms of refactoring specs and so forth that are being done by other teams. And then over here, there's publication pipelines. So it's basically single source of data, many different forms it can take is the pattern here. So when it comes to what we're trying to do, I think on the left I talked about our current system is it's all in XML. But it's organized as documents. So you have document objects like sections and subsections and paragraphs and tables and figures, and then we've annotated that document structure with semantic information, and we've been able to get a certain way. We've gotten we can produce tens of thousands of work instructions for a very small set of specs, but we have a lot of other sorts of specs. So it's just not scalable. And so what we're trying to do is turn that whole representation on its head. And when we are modeling, and also we're going to model a portion of a spec, we're using RDF. It's going to be the primary representation of the information, and we can derive documents from it. So the idea is you have a document, it's already has a basic format. We will decide to take maybe certain sections and turn that into RDF. The other part of this is when we write Sparkle queries, there's in our world, documents refer to other documents, like I showed in that one chart. So when we want to do a query to find like the torque value for the stack up nut bolt material stack up combination, we already know the set of documents that are in scope. So when we run a Sparkle query, we will just focus the query on the set of on those sets of documents that have the embedded triples. So anyway, when we can focus the query like that, well, certainly there's a performance advantage, but there's others as well. So here's some. So So one thing, when you work in modules of RDF like this, it's much easier. There's a set of triples that have a specific focus and context already established by the document that you're modeling. So that makes it easy to manage them. Also, you inherit security. These documents already have all the export control and proprietary, all that sort of marking is already there. So the RDF that's embedded inherits all that. There's document componentization, where there's a lot of reasons we break documents up. That the RDF and the embedding of RDF is not contrary to that at all. And it also makes it easier to produce a document view if you start with this embedded triples. Even though we're moving to a world where we're modeling data, not documents, we still need to produce documents. Just because the legacy of everything that we've done and the way the documents are used for, the consumer base needs that, and there's just all kinds of reasons. So another thing is applicability conditions. So a lot of times if you try to model applicability conditions in RDF, you end up making RDF statements about other RDF statements. It's called reification, and that's complicated to work that way. So we're taking most of those conditions and moving them outside of RDF, and in this document framework, it kind of matches, it works nicely. And then the efficiency gains. So for all those reasons, that's why we're using embedded triples. And it does help with incremental, transformation from a document model to a data model. And that's important to us because these documents have a lot of different customers because they're used throughout the whole value stream. So we'll focus on, right now we're focusing on manufacturing, what do manufacturing engineers need, what do mechanics need. Later on, we'll probably focus on quality assurance. So incremental transformation is important. So I wanted to talk about how we're going to migrate from a document structure XML to RDF. And really that involves several different steps. One is refactoring. So we're taking existing document structures and refactoring, reorganizing the content, breaking it up. And we also have an ontology that we use in order to drive the refactoring. So we have semantic tag that just provide categorization of topics driven by the ontology. So it's like one step forward, so you know what information has got a certain kind of context and what the information's about. So in process specs, for instance, you have categories like processes and process steps and resources that you use in the manufacturing process, just basic categories of information. And we're doing that with some AI assistance. So there's a group, Australian government has a research group, CSIRO, that we're working with. They're helping us with some of this AI assistance tools that eventually will be incorporated into MarkLogic. And then the other part of this is actually generating the RDF. So the same ontology that helps with the initial refactoring also helps with the generating RDF. So you have refactored specs. This is all with a person in the loop, so it doesn't have to be it doesn't have to be correct. But I think that the focus of this use of AI makes it so the amount of hallucinations is going to be small. It's not an open-ended thing. We're providing through a RAG-like approach. It knows what the context is of what we're trying to solve. So that's. So we're also looking. Eventually, we're looking at the new version of MarkLogic, and I think the vector search stuff is going to be interesting. It probably won't be this exactly, but we have a lot of need for specs that the combination of specs. So Boeing is it's a merger of a lot of different companies. There's Boeing and McDonnell Douglas. McDonnell Douglas is a merger of Douglas and McDonnell. And there's actually a whole bunch of other companies that have been merged into Boeing, and they all have their own collections of specs that cover the same sorts of materials. So I think that's one thing we'd like to do is find similarities between content. So I think that covers everything here. Not sure how I'm doing on time. So the last part, I guess, the ontology that we're developing. So we're using, usually you think of OWL as an ontology language, which, has been around for a long time. We're using something called Shackle. I don't know if you're aware of it, but the reason we're using it, and the reason it was built was to support validation, where OWL has an open world assumption, and it's used for things like interoperability between information sources that are not centrally controlled. We're trying to build an ontology that allows interoperability between known environments like different manufacturing sites. And it's really important, and it's really important that, how do I say this? We have lots of documents written by lots of people over a long period of time, but they have a very precise meaning, and they have to be, we need an interoperability between them. So it's more important for us to be able to make sure that the documents all are, the RDF is all interoperable, and the concepts are brought together. There's no ambiguity involved. So we have a group that is working on the ontology part, and we have another group that's working on the refactoring part. So there's teams that are working independently, and it's all going to be brought together in a MarkLogic-based environment. So maybe a little bit different use. I don't know. Shackle it's a W3C standard, just like OWL is. But it was specifically created to support validation versus OWL that can do inference. Okay. And then beyond that, a separate use for MarkLogic that we're thinking of is to support distribution. I think I showed you that umbrella chart before. We have systems that talk to a lot of other systems. We have a lot of potential other, once we start rolling out this sort of data, we need distribution systems that can scale. And so because we're already using MarkLogic for the content, we're thinking about using it for distribution. But the nature of that's going to be redundant servers that can operate at scale. All this is going to be service-based. So we have let's see, there's an enterprise-wide approach to how this is going to work. We have receiving systems that on the BDS, on the military side, on the commercial side, that some of them are older, some of them are newer. So we've set up the approach, but we haven't really worked with MarkLogic yet to figure out how that's going to all happen. But it looks like it looks like it'll be capable, but we'll see. And anyway, so that's kind of the next step for us. So I think that's the end of my slides. Are there any questions on any of this? Could you say the last part again?
How do you determine what the logical break is in those big documents?
Jump right into that right there. All right, thanks.
Those specification documents are probably pretty big. How do you determine what the logical bounds are for breaking them up and relating them to the graph?
Well, all these documents have a precise way they have to be interpreted. You're right, some of them are like 90 pages, 100 pages, or more. And they are, the thing that all these specifications only have use when they're called out in the engineering. So an engineer will say something like, I need to make this part out of this particular material. And so given the context of the design and the way the spec has to be interpreted, all the applicability conditions and the parts of the spec that you have to navigate through are all set. So there's subject matter experts that answer those questions, I guess. Is that an answer to your question? Wait. Uh-huh.
Hi. You refer to documents. Are they actual physical paper documents? No, thanks. You refer to documents. Are they actually paper physical documents?
They would be physical if we printed them out. They're PDF documents.
They're PDF, okay.
Yeah.
And are you proposing to transform them into your internal markup language?
Yeah, we have our own XML markup. It's custom, it goes to this typical turn it into formatting objects and render it as a PDF. Technical documents are published in aerospace and other technical pubs. It's kind of typical that way.
Thank you.
Yeah.
Thank you first. I'm just wondering, what do you think if this methodology can be applied to, say, construction or automotive industries? What's your thought?
I think so. We have we're working with other aerospace companies now to try to come up with a standard for standards. So we're trying to standardize on how all this stuff is representative. And I think automotive is very similar, right? They have. I think they even use some of the same standards. So I think it could be applied. Yeah. I think what makes for us we have there's a lot of variation. We build I think what automotive have a lot more you're producing a lot more units per design than probably we are, right? And we have a lot of variability from customer to customer even, so we have to account for all that. But I'm not sure that really changes things. So I think yes. Any other questions?